3.3e is the last letter that we are doing in section 3.3. 3.3e deals with the concept of perpendiculars. If you've been paying attention, each letter that we've covered, A, B, C, D, have dealt with one new concept in your proofs. So this will be the last of the concepts that we add to our proofs. We're not going to have anything else dealing with any new concepts in proofs. Other than section 4, we'll have a little bit more proofs. And then we get into some basic math in 3.5 and 3.6. The first thing that I need to tell you is that we're still dealing with proofs. So we still follow the 7 steps that are in 3.3a's notes. The major concept that we're dealing with is this word perpendicular. There is a symbol for it. If you like writing out all those letters, feel free to write out all those letters. But if you want to use the symbol looks just like this. It's an upside down T. An upside down T, if you see that, it means it's perpendicular. Anytime you see that, it means it forms a right angle. For example, if you see AB is perpendicular to BC, what that means is that you have a segment that is a perfect right angle to each other. When you see that AB is perpendicular to BC, you can write this right angle symbol in between those two segments. It's very simple. What else you could do is you could know that this perpendicular isn't just on this side. Sometimes, if this thing goes out even further, you can add the right angle symbol on the other side as well, just so you are aware. So, since we are in proofs, the reason why two angles are right angles, a lot of times you're going to say, oh, I know these are right angles because I'm using this word's definition. What word is this right here? It's the definition of perpendicular. When you're writing your proofs, if you ever are saying that two angles are right angles, you can say that the reason is because of the definition of the word perpendicular. Or, if you want to use a symbol, the definition of that upside down T, which means perpendicular. Remember, since you are in a math class and I am a math teacher, you can write the symbols that I write, and that will be good enough for me on any quiz or any test. If you are trying to state that two right angles are congruent to each other, the reason why two right angles are congruent, you can say all right angles are congruent. Matter of fact, I usually abbreviate this to right, and I use the angle symbol. Right angles are congruent. I usually abbreviate it to something that looks like that. The last thing that I need to state before we get into some examples is this. Just because you say that angles are right angles doesn't mean that you can jump into side, angle, side, or angle, side, angle yet. You can't just go, oh, these are right angles, and then jump to this because you haven't proven that the two angles are congruent yet. So make sure that you do these two things separately from each other, which means first you say that they are right, that's a statement, and the second thing you do is you say that those two things are congruent to each other, which would then allow you to use the 5 shortcuts that you learned in section 2. So the example that I have is number 4. Number 4 is on your worksheet, so if you want to do number 4 with me on your worksheet, you are totally welcome to do so. Number 4 looks just like what you see. I hope it matches up with what you have. And It's a 2-column proof, just like all the other letters we've had so far. I sure hope you know what your first statement is going to be. By now, we should know that our first statement is always writing the given statement as our first statement. What does that mean? I follow everything after this and I write it down. E is midpoint of DC, segment DC. Then DB is perpendicular to DC, and AC is perpendicular to DC. I'm hoping by now we know what the first reason is, and if we don't know, we can look at those 7 steps that we had written down in a previous set of notes. But our first reason is always given. And then what I would do if I were you, over here it says add congruent marks to your drawing. I would just add to your drawing. Like what did we just state? Let's add that to our drawing. E is a midpoint of DC. This, I'm going to circle it. I'm going to put midpoint right next to it, just so I have that in my drawing. That might help me. And that's what's going to lead me to know what I should do next. If you're wondering, like, what do I do next? How do I know what to do for for the second statement? What did we write down previously that we could use? You just told me that this is a midpoint. That's exactly in the middle of something. That means that 2 pieces in both triangles have to be the same, and I'm hoping that this will lead you to your next statement. If that's the middle point, and it is the midpoint of DC, of this from here to here, if that's the midpoint, do you know which 2 pieces have to be the same as each other? Let's make that as a statement. What letters? I go over here to my statement and I can say segment DE is congruent to segment EC. How do I know that? I'm using a word. I'm using this word, midpoint. Is that a good enough reason? Close. We're using its definition. I will abbreviate this to definition of a midpoint. I know that these 2 are congruent to each other because of the definition of a midpoint. Okay, so I have that. What else could I do? I'm not sure yet. Let's use what else is given. DB is perpendicular to DC. DB is perpendicular to DC. What does that mean? That means that this angle here is perpendicular. I can put a little right symbol right there like that because it's perpendicular. DB is perpendicular to DC. And the second thing is that AC is perpendicular to DC. AC, DC. Back in Black. That's a song reference for those of you who don't know. AC/DC. Okay. If you don't know that, then you do not know classic rock and roll. And you need to live a little. And open up your Spotify accounts and listen to some old stuff, because that's old stuff is where all the new stuff comes from, and the new stuff just doesn't have the same rock and roll like the old stuff does. Okay? That's an old man's opinion. We have a side. I have this. I need to say something about why I know these are right angles. First off, what should I do? I should say that number 3, angle, BDE, and angle, ACE, are right angles. How do I know that those are right angles? I'm using something from my given statement. If you're not sure, we wrote it down in our notes. Why do I know that their two angles are right angles? It's because I'm using the definition of the word perpendicular. So for number 3, I'm going to use the symbol, the definition of perpendicular. But I can't jump into side angle side yet, or anything like that, until I prove that the angles are congruent to each other. So now I can actually go and say that angle BDE is congruent to angle ACE. I know that seems redundant, but you have to prove that the two angles are congruent to each other to use one of the 5 postulates. If I'm saying that they're congruent to each other, how do I know? Since all right angles are congruent. That's what we wrote down earlier right there. All right angles are congruent is the reason why two right angles are congruent to each other. So far, in my top triangle, I have an angle and a side. In my bottom triangle, I have an angle and a side. I'm almost there, but I need 3 things: a side, an angle, a side, or angle, angle, side, one of those choices. So there's something else from a previous lesson that we could use here. And I'm hoping you see that my 5th reason is going to have to do something to do with vertical angles are congruent. I hope you can see that, because that was letter B, I think, 3.3b. Do you know which angles are vertical angles? The ones inside both triangles? We're going to say angle DEB in the top one. Angle DEB is this one. D, then E, then B. And then I'm going to use CEA. And now you have enough information. You have an angle touching a side, touching an angle that matches with another angle touching a side, touching an angle in another triangle. Since they both match and they're in both triangles, I can now prove that the two triangles are congruent to each other, which is what we're trying to prove. We're trying to prove that triangle AEC is congruent to another triangle. Let's make sure it matches. AEC should match with triangle BED. We'll put that up here in the top as well. And I know they're congruent to each other because of angle, side, angle. This is our longest proof yet. Some proofs are a lot longer. Some proofs take 6, 7 steps. Sometimes you only need 3 steps. But what we had to do was figure out all these things that were congruent so we can say that it was angle, side, angle. We'll stop your notes right there.